asked you, so today's a big idea about average value. Let's start off with the numerical introduction. If I asked you to average those 5 numbers, so what's the average? Mention. Usually there's somebody that has this kind of number set. 9. Let's say, why? You added all those up and divided by 5?
So like you see like 84, 96 divided by 2.
Okay. All right. So the idea that I want to touch on is that you can look at basically a net change of 0. 90, the average has to be in the middle somewhere. Do you agree? So what I assume that he did is took a stab at, and it looks like 90 is about the middle. Okay? Now, with respect to 90, this is 2 below, and this is 2 above. So they average out to 90. This is 6 below and 6 above. So they average out to 90. And then obviously 90 averages out to 90. And so the average is 90. Now, you could think of this then as the net above and below cancel out. If you were to think of this graphically, let's say we looked at these from lows to highest, 84, 85, 86, 87, 88, 89, 90. Oops, I didn't make this. I'll go with, we'll go by 2s. 86, 88, 90, 92, 94, 96. All right. So we're saying basically that 90 feels like the middle, yeah? If you were to think of this graphically, then 88 is 2 below. And 92 is 2 above. And 84 is 6 below and 6 above and 90. So we could say that the area above the average equals the area below the average. We? Cool. Now, that is the idea of average value, except in calculus, you don't just do 5 points, you do infinitely many points. You're going to average infinitely many numbers. Let's think graphically, which shows infinitely many numbers. If I ask for each curve to sketch where you think the average y value would be, and then estimate that y value, let's do one together. So from here, y equals x squared, from 0 to 4 on each side, just ballpark, where do you think the y value would be, the average y value? Would it be up here? Obviously, that's ridiculous. It has to be in the middle somewhere. So, would it be here? Why not? Okay, now think in terms of area. I want to find a place where the places where the area above or the underestimate is negated by the area below or the overestimate versus underestimate. I don't remember what I said, but you get the idea. So I think you'll agree that that area under is way more than that area over. Yay? You want to try and find it where it would be roughly equal. So I'm going to say a little more like maybe here. So that this area under, I still feel like that's a little low. Maybe here. So that that area under and that area over under, that still feels like a little high. So maybe let's say the average value is, I'll say 6. That's what you're to do. You with me? And that is an estimate, by the way. I'm just taking a stab at it. Do you understand what you're doing? Cool. Oh, goodness. This, by the way, is -1 here at the minimum on the last one. All right, are you ready? Super. Give me an answer for the second one. You can't be wrong. Well, you can be really wrong, but I mean, just ballpark estimate. Average value is? Around 2-ish. I agree. If you throw it at 2, the area below and the area above is roughly equal. So F at C is around 2. All right. What about the next one? Given that the average value, or the minimum is at a y of -1, the average y value is? -1/2. I agree. That seems about good. All right. You with me so far? Cool. All right. Given each curve, sketch and estimate the average value and estimate the x value at which it's made. So this is what I want you to do now. I want you to first sketch where you think the average value would be. 2, 3, 4, 5, 6, 7, 8. Where do you think I should sketch the average value? 6, 5. Let's go with 5. Okay. So that means that I'm saying the average y value, or f value, is about 5. I'm also saying find the x value at which the average value is made. So the average value is made at an x of, or x equals c of 3. So you're giving me two things. What do you think the average y value is, and the c, or x value, where that point occurs on the curve. Are you ready? Where did you draw your y value in the second one? About y equal? Did you say 2, 1.5, 1, 2, 2.5? I'm going to go. So you've got, that, this is all below. Seems like 2 is a little low. That area seems bigger than that, but I think maybe a little less than 2, but okay. I'm going to say f of c is about 1.8. And what is the c value? For the x at which it's made. The x is about 1.3. Sure, sounds good. Okay? Last but not least, what's the y value, average y value? I can actually calculate it here. What's this area? 1. Yes, great job. You can count boxes. This area, 1, 2. This area is 2. This area is 3. So you have a total of 6 divided by, actually, should we go, I think it's these 4. Sorry, I didn't make that clear. So, what's the average y value? 6 divided by 4. 3 halves, okay. So the average y value is in here. F at c equals 3 halves. That's the average y value. What's the x at which it's made? I love teaching calculus on a Monday morning. There is no x equals c where y equals 3 halves because the curve is not continuous. We'll talk about that in a minute. All right. Now, the question of the day is then, how do you find that average value without estimating it graphically? How do you analytically find it? And how do you find the x that makes that average value? Would you sketch the curve 1 plus sine of x? Then where you feel the, just one period is fine. Then where do you think the average value would be? Where do you reckon the average value would be? 1. You are correct. The average value is 1. Yeah? All right. Now, compare the area under the curve in both cases. Okay, so we said that what makes an average is that the area above should cancel out the area below, yeah? So if I took this area here, this blue area, and turned it over and filled it, it should fill that hole, they should be exactly the same, yeah? Yeah. Okay, so what I'm saying then is the area here should equal the area here. Area under sine should equal the area under the average value. We agree on that? Okay. Cool. How would I find the area in the first one? Integrate from 0 to 2 pi of 1 plus sine of x. Yes, yeah? What about the other one? So let's start here. Do you agree that our average value we think is f at c, and we know it's f at c. We think it's 1, but we're going to verify that, all right? So f at c is the average value. Cool? So how do you find the area of that rectangle? F at c times 2 pi for the base, based on type and all, yay? All right. So now let's say we wanted to find f at c. Doesn't that mean f at c is what I would get if I divided the 2 pi over and found the integral? Do you understand? I solve for f at c because that's the goal. Okay. What is the antiderivative of 1 plus sine of x? X minus cosine of x from 0 to 2 pi. 1 over 2 pi. When I put in 2 pi, what do I get? 2 pi minus 1. When I put in 0, what do I get?
-1.
0 minus 1. What is the sum inside the brackets? 2 pi. And therefore, the average value, f at c, must be... Now, this idea of there's got to be a rectangle with equal area, and the height of that rectangle is the average value, is the big idea behind average value. If you start by saying area under a curve equals area under the average value rectangle, and you say the area under the curve is an integral, and the area under the average value rectangle is the average value times however big the base of the rectangle is. Now, the base of the rectangle depends on the region that you're finding the area under. So it's basically the right endpoint minus the left endpoint. Then if you solve for f at c, because the goal is to get a method for finding what is the average y value, then we would divide over the base of that rectangle. And that's where the average value idea comes from. Area under the curve divided by the base of the rectangle equals the average height rectangle. So this is average value. Now read carefully, please. Always read for average value versus average rate of change. Average value is this idea. Average rate of change is what we've been doing forever, where you're finding a secant slope or a rate of change over an interval. They're different. Don't confuse them. Read carefully. All right? So, with that said, let's try a simple problem. Say I asked you to find the average value of this function on the interval. Start by setting it up. I'll get you set up and then we'll get going. Average value is a specific numerical value f at c. And so using this idea, we would find this by taking 1 over pi over 2 minus 0 times the integral from 0 to pi over 2 of 3x plus sine of x dx. Now I have no idea what that curve looks like. It probably has a sine field, but with a slanted center line. So the graph probably looks like that if I graph it, but you don't need to do that. Find it without a calculator, please. These are largely, do you understand how to find average value, and do you have integration skills? Distribute what you could distribute. How are we doing? Yeah, we're good. Andrew? Okay. Any questions about where I'm coming from? Did you get something different than me? Or are we all in agreement? Okay, cool. Let's move on. Now, back here, when I did this picture, most of these have an X where the average value is made. There's a case that makes that place. However, in this case, there wasn't one. There wasn't an X on the curve where that average value occurred. It was kind of in between chunks, and that was because it wasn't continuous. Now, that is a reference to the unfortunately named mean value theorem for integrals. Now, the minute they named it that, well, they made confusing it with the regular mean value theorem a major issue, and we're going to have to battle through that. There is a reason for it, but for now, just read carefully. I beg you, just read carefully. There's a big difference between mean value theorem for integrals and mean value theorem, period. If they say mean value theorem, that's a reference to the one we've been doing. Average rate of change equals instantaneous rate of change. This is the mean value theorem for integrals. If a function's continuous on a closed interval, there must be a point inside or even at the endpoints such that blah-blah-blah be blue. Now, if you were to put that in plain English, you would say there is an x equals c where the average value is made. And if it's the case that they want you to find that, then you're really working both sides of this average value, okay? So, for this case, just so we're clear on the question, all right, f is 2 plus x cubed. I got you, there's a cube graph, that's what it looks like. Find the c guaranteed by the mean value theorem for integrals on 1 to 2. Now, that is to say that if you were to find the average value on 1 to 2, it might be about here, yeah? What is the place on the curve where that average value is made? That's this, is what I'm looking for. You follow? Now, to do that, I'm going to do, like I said, both sides. And it's up to you whether you work one side, then the other, or both every step. But I first need to find where is the average value made. And that's at 1 over 2 minus 1 from 1 to 2 of 2 plus x cubed. Integrated. You down? Now that then is 1, thankfully. What's the antiderivative? 2x plus 1/4 x to the 4th from 1 to 2, which eventually is, what do we got there? 4 plus 16/4 minus 2 plus a 4th. Do you agree? All right. So, what does that total up to be? What are the whole numbers total up to be, my friends? 4 plus 4 minus 2 is 6. Okay. 6, take away a 4th is 5 3/4. All right. So the average y value is 5 3/4. Do we all agree? Now, all that said, that's great, but I want to find where is the x, or the c really, the specific c where that curve is made, where that value is made. So I want to know, when does the function 2 plus c cubed equal 5 3/4? What's the x value where that y value was made? So now, after I found the y value, I need to go back and say, all right, the x must be this. How would you do it? C cubed equals 3 3/4, which is, at this point, I guess I'm going to have to, now let's just go with it. So c is the cube root of 3 3/4, which is probably between 1 and 2, I would imagine. No, of course, never mind. I can see it is, obviously. Are you following me, people? Okay. Try this one with its calculator active. These, you'll see, have good distractors. I first need a calculator. So many windows open. So you'd be wise to do a little paper and pencil work before you use your calculator, because you're not ready to use your calculator yet. All right. All right. All right. What do you say? A, B, or C? B. Okay, C? B. Others? B? Okay. So the one number I can definitely rule out before I even do the problem is B. B's gone. B has zero chance. Why? It's not in the interval, people. Okay, so B is a no. It has to be in 7 to 8, and that most definitely is not in 7 to 8. So B is out. I could be totally clueless and say B is definitely not it. I didn't even need to pick my calculator. No, that's not an issue. Okay? Now, that said, would you agree I need to figure out this answer but find C, yeah? All right, now when you integrated this right side, that's where this came from. The AP test is famous for putting intermediate answers, okay? So in other words, trying to get you to bail early and say, oh yeah, I see that number, there's a choice, I'll go with that. Even though we're nowhere close to done with the problem, many people will still say, yeah, that's it, there it is. You're not done. That's not the answer is what's C, not what's the average value. So guaranteed the average value will be there. Don't bite on it. Now, after that, you probably picked up your calculator, and I hope you picked up your calculator, because if you solve this analytically, sine of 2c is 0.5472, and then you did inverse sine of that and divided by 2. What is your calculator programmed to do when you do inverse sine? Lava zones, yeah. It is programmed to give you negative pi over 2 to pi over 2. Well, that is not where you're looking for an answer. So that's not going to work. You're going to need to think more graphically. So the very first thing you should do after you get your equations in, there's my curve. There's my average value. I stored it to A. After that, before I find intersection points, you set your window to the appropriate window. You should set your window to 7 to 8, so you don't look in the wrong place like many of you did. You set your window to 7 to 8, then you find the intersection point, and it is 7.654. Okay, so set window, use intersect. Okay, there is C. Okie dokie. Let's go on to, now, this average value idea is very common in free responses. You know all those problems where you interpret the integral? This is a new version of interpret the integral. So look at this problem here. Given the number of problems the student has to do at any time, t, since the first day of school, given by that function, which kind of obviously goes up and down, and probably isn't a great model, but it'll work. Okay. If I asked you to find and interpret n of 8, would you do that, please? calculate what n of 8 is without a calculator. You should be able to do that without a calculator. And then interpret the answer in the context of the problem. Okay, so is your answer 13?
Yes.
All right, interpret your answer in the context of the problem. All right, so you could put the time first or later, I don't care. At time equal 8 days since the start of school. What else? What's going on? What is 13? The student is changing at a rate of, or has 13 problems to do? Has 13 problems to do. Okay? Find and interpret and primary, please. Okay? What's your numerical answer? 5. Okay? And interpret, please. At time equal 8 days since start of school. Okay, so on the AP test, they will usually ask you to interpret the nature of the rate of change. Not just is it changing at a rate of, but is the number of problems increasing or decreasing at a rate of. So you need to interpret the sum. At time equal 8 days, the number of problems is increasing at a rate of high, what units? Problems per day. I guess that means the teacher's assigning more than he's doing, or she's doing. You down? Okay. Last but not least, this is the idea of the day. When you see a fraction out front of an integral, fraction in front of an integral, think average value of whatever's here. So don't worry, we're running out of time, so we're not going to integrate this. We could put that in and integrate it and get a number. I know, just by basic sinusoid knowledge, that whatever that number answer would be, it should be between, please tell me the answer is. I can tell without integrating that the answer would be between, what's the least this could be? 11, and the most it could be? 15. So whatever this comes out is between 11 and 15, I know that. All right, so let's say it's something in there. We would say, first let's refer to the time interval. From 2 days to time equals 6 days, the what? Average number of problems the student has is whatever the number is. You follow? Yeah. All right. You will be asked to interpret an integral expression for average value 20 bits. All right. What weekend homework do you have? One homework or two? The whole, so. Well, what do you got there? 88A and B? All righty then. So, let's get at least one of those turned in, shall we? Do-do-do. Oh, goodness. I think we did those. That's good. All right. On 88A, I think we did those. How did this go? All right, so let's go here. So I tried to write you a note, but I'm sure many people, I know at least one person I talked to and said ignored it. All right, so in B, they ask you to write a tangent line equation, yeah? It's very common for students to think, oh, geez, well, how am I supposed to write a tangent line equation to this if I don't know the equation? So I really should have to integrate it first. Then once I know the equation, then I can do the tangent, right? Totally wrong. What do you need for a tangent? A point? Do they give you the point? Yes. What do you need? What else do you need? A slope. Do you have what you need for a slope?
Yes.
You do not need the equation to write a tangent. They didn't get the order wrong. They asked you to get the solution later because it is ridiculous to integrate so that later then you can say, okay, now I take the derivative to get the tangent. That's ridiculous. You already have it, all right? So you do not need to integrate first. The point is 1 root 3. The slope is dy dx at 1 root 3. And therefore your slope is something like 2 over root 3. Oui? Yes. So your tangent line is y minus root 3 equals 2 over root 3 x minus 1. Check that. First of all, do you have the tangent line correct? All right. Second, it says use it to approximate f at 1.2. Remember when you have a curve and you draw a tangent line at a point, you can use that tangent line at points nearby because the y values will be pretty close to the same. That's a big idea of calculus. So if you were to say f at 1.2, what is it close to? First of all, it's an approximation. So that's key there, is you say this is approximately equal to. Second, how do I get the approximation? What do I do? Plug in 1.2. So integrate that I need to move over root 3, so this would be root 3 plus 2 over root 3 times 1.2 minus 1. There's your estimate. You follow? All right. C then is separation of variables. So did you separate the variables properly and get something like y dy equals x plus 1 dx? All right, then check your answer. Eventually, after a whole lot of calculus, I got y is the square root of x squared plus 2x. How'd you do that? Is that what you got? Okay, and you had a whole lot of work in between, integrating, finding c, plus or minus, choosing plus or minus, right? Based on now the fact that you really know the true curve, not just a tangent line estimate, now you can say, well, now I know that f at 1.2 is truly equal to whatever that is at 1.2. I have 1.9595. You down? All right. I believe that the 2 in the middle we did after the exponential lesson. So 3 and 4 we did, yes? Okay, and then 5, I have 8 pi over 3 for 5. And for 6, I do not have a calculator, so I do not have an answer. What is the answer to, I don't even know what that is. parabola looks like. Where's the vertex? 3. Anybody have a volume for this bad boy? 32-ish. Anybody can you say confirm that? 32.596. Excellent. Thank you, Joanne, for having the courage to say that. Thank you for confirming. All right. What about 4 in the front? Does anybody have a volume for that? 32 pi? 32 pi over 15? Okay. All right. Anything you'd like to ask about real quick on 88A? If not, I guess 7th hour it is. 88A is due today.
3 on the back.
Anything you want?
3
on the back.
3 on the back?
Yeah.
3 on the back, we already did that. I refuse. 5? 5, yes. 5 is this, yeah? So the idea for 5 is you had to understand to get a positive volume, you had to, what did you have to, so volume is 2 pi x f of x, generally, but in this case, which is negative, the x or the f of x? F of x. So you should have been taking the opposite of the curve here, opposite of f of x to get a positive answer. And the integration, if you distribute, isn't too bad. Okay, so 88A is due today, yes? Not B.
No. I'll talk about that.
Oh, of course you were. Yes.
So I was gone on Friday when everyone turned in 87B.
Okay.
Is I supposed to know how to do this?
You can see it.
Okay, hold on. Okay, thank you.
Sure.